Hello guys, welcome you all to this video. Here we will solve few more questions regarding this chapter of countability, and also we will discuss the answer of those questions which I gave in the last video. Okay, so stay tuned till the end and you will get something helpful from this video. Fine, so let's start with the question number 9. It says that which of the following are uncountable? Read it carefully. That first option, it says that the set, suppose A, it is collection of all such functions which are from n to 1 2. So what will be the cardinality of this set? Cardinality of A, it is going to be cardinality of this set to the power cardinality of this one. So 2 to the power alephnot. So it is C, and it is nothing but cardinality of R. So A is equivalent with R. Thus option A is correct. Fine. Alright. If you consider the second one, that is B, F such that F mapping from 1 to, and consider its cardinality, it is nothing but alephnot to the power 2, so it is alephnot. Fine. This is nothing but cardinality of n, so B, it is going to be equivalent with n. That implies B is countable. So B is not our answer. Fine. Okay. If you consider third option, that is C, F such that F is a mapping from n to 1 to, satisfying this condition F1 less or equal to F2. Just observe it carefully that it is in fact a subset. Here I have considered it fourth option, no? So just take a pause and we will discuss it. Consider for the third option, okay, which is I'm just treating it as D, and it is F, so that F is a mapping from 1 to n with F1 less or equal to F2. This is given in the option number 3 or C, correct? And observe it, this is in fact subset of your, you can say, B. This is subset of B. Fine. And B is countable set, correct? B is countable, just shown it here, over here. B is countable. So a subset D is a subset of B, and B is countable. So it is never possible that D is uncountable. Clear? By that simple logic, you can discard your third option. D has to be countable. Okay. Fine. Now consider fourth one. Just if you consider this fourth one, and in fact it is subset of first A, but A was uncountable set. A was uncountable set. So subset of an uncountable set, it may be countable, it may be countably infinite, it may be finite set, it may be uncountable set. So by this previous logic, we cannot eliminate this option number D. So we have to use a certain approach for that. How we will proceed for this option? Just understand the treatment what we are going to use here. Look at f is the mapping from n to 1 2. Fine. So 1 2 3 4 5 6 7 and so on going on. It is the set of all natural number, and you have 1 2 in the codomain set. So one simple restriction is there, that f1 should be less than or equal to f2. So 1 under this mapping, 1 goes to 1 and say 2 goes to 2. Fine, this is fine, because f1 you are getting as 1, f2 you are getting as 2, and it is satisfying this condition f1 less or equal to f2. All right, okay. But it is not allowed that if you map f1 as 2 and f2 as 1, it is not allowed in this case. Okay, such restriction is there, and rest of the elements, look at 3 has two choices, because in the codomain you just have 1 and 2. 3 can either map to 1 or it can map to 2. 4 has similarly two choices. 5 has similarly two choices. 6 has similarly two choices. 7 two choices. And thus, how many choices are there, or how many simultaneous ways are there? 2 2 2 up to alephnot number of times, because only restriction in the finite case, that is 1 and 2, there are the restriction. But here you are getting 2 to the power alephnot, that is c, number of choices by which you can give this or you can construct this whole set. That is cardinality of this c. It is going to be c, which is nothing but cardinality of r. Thus c turns out to be an uncountable set. Fine. Okay, so your answer should be, I think, option A and option D. Okay, fine. If you got the answer, then clear. Otherwise, just think little bit and you will get the whole picture in front of you. By that similar kind of approach, try to give me the answer for question number 10. Okay, I can assure you that if you have the proper understanding of previous videos as well as the questions what we have discussed in the last video and question number 9, you can surely solve this question number 10 correctly and give me the answer in the comment section. Fine. In fact, you guys try to give me the answer, and in my Facebook page I will post the answers as well. Okay, so no issue with that, but try to solve the question by yourself. That will be benefit for you. Okay, now I'm coming on to the question number 11, and here in question number 11, a very big giant size of statement is there for a set x. Let px be the set of all subset of x, and it is omega x be the set of all function, like this way. And then what about all these options are there? So x is a set, px, it is basically power set. Omega x, it is collection of all those function from x to 0 1. In fact, this one looks like some set which has the same cardinality as of px. In fact, it is another form of having of the power set. Because look at cardinality of this omega x this is nothing but 2 to the power x, and cardinality of this px, it is same 2 to the power x, correct? Fine. Now with this knowledge we are moving on to the options. If x is finite, the first option says that if x is finite, then rho x, okay, rho x is finite, correct? X is finite. Then just wait, it was rho x, no? I gave you as px, so just take it as px, no issue with that. So px cardinality, it is going to be 2 to the power x, and if x is finite, so this quantity is obviously going to be finite quantity. So first option, there is nothing special, it is correct. Fine. Now we are coming on to the second option. If x and y are finite set, and if there are 1-1 correspondence between rho x and rho y, that is px and py in our notation what we have used here, then there is 1-1 correspondence between x and y. So what they are talking about, that px and py, there is a 1-1 correspondence, so in fact they are equivalent. So their cardinality, that is 2 to the power x, it is going to be 2 to the power y. Fine. As x and y are finite set, so immediately what you can write, cardinality of x, it is going to be cardinality of y, correct? So look at two sets having the same cardinality, that immediately implies x is equivalent with y. Fine. That implies there exists a 1-1 correspondence, 1-1 on 2 in fact, because there is bijection between x and y. Fine. Thus your option B is going to be correct. Fine. Alright. There is no 1-1 correspondence between x and px. X and px. Because P has 2 to the power x number of elements. 2 to the power x number of elements. And that is the cardinality of px. In fact, this one is not equal with x. Correct? This one is not equal with the cardinality of x. So there is no question of getting any 1-1 correspondence between x and y. Exactly, option C is saying the same thing. So option C is going to be correct one. There is, in the fourth option, they are claiming that there is a 1-1 correspondence between omega x and px. Exactly what we got in our very first attempt of this question, that cardinality of this omega x, it is 2 to the power x, and cardinality of this px, it is again 2 to the power x. So their cardinality, that is cardinality of px, it is same as cardinality of omega x. So they are equivalent. In fact, px, it is equivalent with omega x. So there is 1-1 correspondence between these two sets. So option D, it is again to be correct. So all the 4 options are correct. In fact. Fine. All right. If you have any question, then you can use the comment section. Fine. And for your knowledge, I am just mentioning one thing, that we have one Facebook page, namely Maths Beetle. Maths B, here is a little change in the spelling, BETTLE, I think so. You just go to the Facebook and search it, Maths Beetle, and in the subsequent videos, whatever questions we will discuss, some question solution we will provide in the video, and rest of the question we will provide in the format of PDF or photo in that Mathsbeetle page. So do like this page and stay connected. Fine. Mathsbeetle page in Facebook. Okay. Now come to this 12th number problem. Read it carefully. S is the set of all these points satisfying this condition where n belonging from n, either x belongs to q or y belongs to q. Obviously q is rational and n is the set of all natural numbers, and which one is going to be correct? That S is countable, uncountable, empty, finite, whatever. Okay, so just get the idea how to proceed for this question. Xy such that x square plus y square by n square. N coming from natural number, x coming from q or y coming from q. Fine. If you consider n is 1, then what you have? X square plus y square equals to 1. That is basically area, you can say the points on this circle having radius 1 and center at 0, 0. The points on this circle, but the points, which points? X may be rational, y may be rational. Okay, so whatever may be the scenario, you will get the points on this circle. This is, you can say, as your S1. Fine. If you consider n equals to 2, then you will get x square plus y square as 1 by 4, and that is nothing but points on this circle. That is, you can say S2. Similarly, you will get x square plus y square as 1 by 9, that is your S3. So you will get the points on this circle. So thus you will get these concentric circles. This one is S1, this one S2, this one S3, and so on. So look at, enumeration is possible, correct or not? You will be able to get S1, S2, S3, S4, Sn, and so on, like this way. And the union of all these SIs will construct this S, correct? So enumeration is possible, in fact, correct? And moreover, observe it carefully that each of these SIs are countable set, correct? Because if you consider this first component, it is either from Q. If you consider the second element, it is from Q or it is from Q. So it has in fact C choices to fill up. Fine. Thus your first S1 is countable, second one is countable, third one is countable, and consider the union, then the whole union, it is going to be obviously countable union. So what you are getting? A countable union of countable set. Thus S is going to be here S. S is going to be countable. Fine. All right. Thus option B is correct. In fact, here if you simply such kind of problems, if you simply able to construct this kind of enumeration, then immediately you can claim your set, your considered set is countable, because enumeration is the main thing to consider. All right. Thus we have solved these problems, and I gave you the exercise for question number 10, and I will also provide the answer for all these questions what I gave in the last video. Like this, for this question number 7, you have the answer as B and D. How? For that purpose, you need to have eyes on my Facebook page, I will give the solution there. Like for question number here, I think this one, no? B. Question number 6, its answer, it is going to be D, option number D. Question number 4, this answer are all, and question number 3, the answer, it is going to be B, C and D. And for this second problem, you have obviously A and C as your answer. A and C. This question, second problem. I saw that some of you gave the answer in the comment section, and fine, no issue with that. And also let me know in the comment area that if you find anything doubtful or if you have any problem with this section, and in the next video onwards we will proceed with the chapter of sequence. Fine, okay, thank you, and meet you soon in the very next video.